Hi, this is Kim from Kimberly Scott Science. Thank you for purchasing one of our science notebook activities. This video is for the bundle, but we put in the YouTube description the timestamp for each section. So if you did not buy the complete bundle, you can look down there and see where your section begins. If you have not purchased this, just look at the YouTube description and you will see a link to be able to purchase the complete bundle or any part of it. So I'm just going to do kind of a page by page of the different sections. Each product includes a cover. We call it our My Science Brain folders, and we keep them in a 3-prong notebook. We find that that works really well for each of our units. The pages tend to tear pretty easily in a binder depending on the age of your students. So the My Science Brain folder cover includes where you put the topic. So if this was 3rd grade, this might be stormy skies. Then you have your essential question, and it's designed for inquiry-based learning. So your essential question is that overall question for the unit, or it also might be driving question. So you'll see we included 2 pages, one that says essential question and one that says driving question. And then at the bottom, there is a my doodle space as well about the topic. So a lot of times I'll have my students write in the question, and then I'll give them time to just doodle a little bit about what they're thinking about for the question. Or at the end of class, I might say, okay, go to your doodle space and doodle one thing you learned today. And then they'll show it to me as they walk out the door. So here's a good inquiry-based question is, what are patterns in the weather? And our whole unit would be about that. And students might use that doodle space and they'll draw some clouds or something, whatever they're kind of thinking about when they first see that question. And then you'll see also we have all of the same stuff on that second page, except we call it driving question, but that really is the same thing. And then we have a my thoughts page. And so this just has questions we have about the topic. Maybe during an investigation, you say, hey, if you guys have any questions, just write them here. And then at the end of class, we can take time to answer them. And new words we have learned. So you have those kids that they just like to doodle and write things down. And this gives them a space to be able to do that. So we hope you will find that useful. And every product contains that. And it also has the digital form. So you could do paperless learning and make a digital notebook as well. Our first product deals with brainstorming. So in this, we have some of the classic brainstorming ways that are wonderful for inquiry-based learning. So you can start your unit out with a KWL. This also can be used for just a one-time activity as well. So KWLs have, what do you know about the topic? What do you want to learn about the topic? And what did you learn? So if you're talking about the patterns in the weather, you would start with, what do you know about the topic? I know clouds are water. And this could be something that they do in pairs. This could be something you do as a whole class. I like to do it where the kids get about 2 or 3 minutes on their own to try to get 3 to 5 things down. Then they consult with their group and they're allowed to write down things that their group knows. Then we talk as a whole class. Then what do you want to learn about the topic? So now maybe you won't get to all of these things that they want to learn, but because it's a driving question or an essential question, you'll leave some room in your lesson plans to have days where the kids get to explore that. So what is lightning? Maybe I'm not really getting into that as much, and my kids would maybe take a day to explore that. And then the what did you learn you can revisit throughout your unit, or you can visit this page at the very end. I'll usually have my last class period where we go through our brainstorming pages and add the things we learned. We also included a horizontal version because I know sometimes kids are writing at different sizes. And sometimes the kids also want to be able to draw pictures of things they already know or want to know, or even draw a picture of what they learned. So the horizontal page gives them a little more room for that. We included a clues chart, which is fantastic for inquiry learning if you've never used one. Your question goes at the top. We included a PNG of this form, and that's so that if you wanted to print it on larger paper, project it on the board, that might make it easier to do that. And it's hard because on the Google slide, it is turned sideways. So that makes it difficult to be able to do that. So these sections are, what do you already know? What are you learning? What is your evidence? What are you wondering about? What science concepts and vocabulary have you learned? So same concept as the KWL. They record what are patterns in the weather, what do they already know. Then you have what are you learning. So now you say what do you already know, but what did we do in class today? So I am learning dust is needed to make a cloud. Okay, they're learning that. What evidence do they have? Well, we did an experiment in class, and in class, the one without dust did not make a cloud, and the one with dust did make a cloud. There is their evidence. And evidence could be even a book that they learned it in, and an example. And then what are you wondering about? So if they still have questions, like the last KWL that said, what is lightning? So I'm still wondering about lightning. So they would maybe revisit that. Or I'm wondering how big are the dust particles? So maybe you take some time for them to investigate that. And then what science concepts and vocabulary have you learned? So they learned about evaporation. They learned about the water cycle. Maybe they learned condensation nuclei, and you would fill that in and revisit it throughout your unit. Then we also have a My ABC brainstorming chart. I love this for the beginning of a unit. They put the topic up there, and then they just try to think of a word that begins with each letter. Sometimes they'll do it as a rally table, and they'll pass a single paper around, and then each kid gets to write something in. Sometimes they'll just have their own paper, and at the end of the unit, we'll revisit it, and I'll get to see how many new words they can think of. So again, it's giving kids the opportunity to see their growth in their learning, and it's just a fun way to get some engagement. The next product we have is vocabulary discovery. So these are all different strategies to help the students learn how to describe words in their own words, to really truly understand what the word means. They're getting experiences in inquiry-based learning, and then they're also getting the opportunity to be able to take what they're learning and put it into words and explain it in written language. So we give you a basic glossary of words. There's the word, they put in the definition and the examples, and you might need more than one page. Then we have vocabulary discovery sentences, which is different. This is where you have your vocabulary words, then they write a possible sentence. So they use the word in a sentence, not the definition. Then at the end of the unit, they come back and write a real meaning sentence, which basically means now that I've had experience with this word, can I write a better sentence? So you have cloud. The cloud looked dark. So that tells me, okay, they kind of know what cloud means. We learn a little bit more about it. They end the unit with a sentence that is, the water condensed to form a cloud. So different than writing a definition, but they're showing me that they can actually use that new word or science concept. Evaporation. I will tell my students they can change it to evaporate, evaporated, evaporating to help their sentence. They may not know what the word means, and then they come up with a funny sentence. He evaporated into thin air. We go through and we do our whole unit. Their sentence becomes, the puddle evaporated into the air. So now I can see the growth that they've had with that word. Condensation. I hope condensation does not hit my house. So then you will see there, okay, I know that student obviously does not know what condensation is. After we do the unit, they write, the water on the grass was from condensation. So I'm able to see, okay, they're understanding a little bit better, and they're able to use it in a sentence versus just repeating a definition. So I really like this activity. It's a lot of fun. And then our next one is vocabulary discovery Foursquare. There are two versions of this. So in the first one, word goes in the middle. Definition, characteristics, so a cloud, white, gray, dark, looks fluffy, moves with the sky, made of liquid water. Then they would give examples of clouds. And then where it gets to getting them to think a little bit more about the word, they start giving non-examples of the word. So I can give examples when I actually think of something that's maybe the opposite or isn't it, that maybe we sometimes confuse and think it is a cloud. And so it gets them to think a little bit deeper about that. And then the second page that we have has the same thing with the definition, but they're now going to have use the word in a sentence. And then in the third box, they're writing a synonym, like typhoons means the same as a hurricane. They're writing an antonym, a sunny day, and then they're drawing a picture. So whatever type of picture they want to do. And you can do research for these too. So this doesn't just have to be off the top of their head. You can use your textbooks and pick a word, and they have to use their textbooks or whatever research methods you have to answer these to help expand their knowledge on it. So that is very helpful. The next strategy we have is really fun. It's called vocabulary switch. And this is where they just switch up the words, silly or serious, and they write it on a scale. We also included a PNG of this in the file too, so if you want to print it bigger to put it up on the board, and again, because it is horizontal, that's a little bit harder on the Google Slides. So here you'll see we have evaporation, Silly words would be things like disappearing act, sky drink, poof. So a real good play on words. Serious words would be evaporation, vaporization, vanish, vapor. And you can see words that are more in the middle, not serious, not silly, hiding water, gone, disappears, sun's heat, liquid to gas. So it's just a kind of fun little play with words. And they can use more than one word, like a phrase as well to describe it. Works great for whole class or groups. The next product we have are exit tickets. So we did include 4 different versions of these. And then we also added blank ones. I do not have the blank ones in this video, but there are blank ones for you to be able to go in and use the same layout. You can use some of these questions, but also ask your own questions. So if you have specific topic questions you want to ask for a unit, you can use the editable versions in the Google Slides. We made these more SEL based. So for the students to kind of really reflect on class, is there anything you would change about class today? Create an emoji to show how you felt in class today. What frustrated you about the topic? They can be cut out and used as little half slips that you pass out, or you can also hole punch them and they date them and you put several in there. And maybe you don't use these every day, but maybe you have after a big activity, you do a reflection and then you go back and look and think about what the kids said. The next product we have deals with observations, inferences, really reflecting on things. So we have a read and react activity. I use this for readings. I know for me, seeing the students only 1 day a week, it's hard to just separate them and have all of them read on their own. And I want it to be a group interaction. So for read and react, we will read a section. I will stop and say react, and they will write whatever is on their mind about the topic. And I will tell you, my students love read and react. I allow them to draw pictures too. There is no right or wrong answer. So students might write, I really don't understand evaporation. Or they might write, wow, I didn't know that. That is so cool. And it's just a really wonderful activity. And then we also have observe and infer. And so this is just another way for the kids to start looking at different things and reflecting and getting their thoughts into written language, which I find is very difficult for kids to do. So, this you would do a demonstration in front of your class. Maybe you're doing something with dew, condensation. They would write an observation. There are drops of water on the can, and then their inference would be why it is there. Then we also have a describe the demo challenge. This is where you would do a demonstration in front of the room and the students would describe it from a different person's perspective: a baby, a 2-year-old, a 5-year-old, an 8-year-old, a teenager, an adult. So this is meant to be fun to get them to think about being more sophisticated in their writing. So if you were to do this activity, a baby might go ooh, a 2-year-old might go wet because the sides are wet, a 5-year-old might say drops of water, an 8-year-old might say drops of water are dripping. How would a teenager describe it? Because they're going to know more words. Water is condensing on the can. And how would an adult describe it? I'm sorry, water is condensing on the outside. The adult might say the temperature drops, causing water to form, water in the air to condense on the can. So they start to get to see how they can write it in different ways. And it's just a fun and engaging way to get them to participate. We provided 2 versions. So the second version for Describe the Demo Challenge has you, your teacher, a scientist, a parent, a sibling, and a blank spot where they can choose a person, maybe like the principal. How would the principal describe it? If they were to come in right now, what do you think the principal would say? We also put a describe the picture challenge because sometimes you just have a neat picture, a neat phenomenon you want to show them. So here's an example with a picture that's got this house that withstood this hurricane and it didn't even move or budge. And then the kids would describe it. How would a baby describe the picture? 2-year-old, all those same concepts. How would a teacher, you, a scientist, a parent describe it? So you can use different pictures and have them explain what they think happened. So that's just a fun activity to even start class out when you're starting something new. Let's see. Take this to the next.
The observe and infer science notebooks, we also added claims, evidence, and reasoning. So this was an addition that we felt would be good, or I felt would be good to add to it, because I know claims, evidence, and reasoning is so important. We put 2 different versions in there. This first one is look at the picture closely, because a lot of teachers do post, say at the beginning of class, a picture, and then the students will do a claim, evidence, and reasoning. If you've never done SIR, it does take some practice for your kids. So we give a little description here about what the claim is, a what you know statement that answers the question, a fact about the demonstration, and you write the question right at the top. Evidence, what data and observations do you have to support your claim? How do you know it is a fact? And then reasoning, explain the why and the how using scientific concepts. So this is going, here is the reasoning for the claim and the evidence. So you could show, like the picture I showed earlier, you could post this on the board in your classroom. When the students come in, they would look at the picture, use that. You would have a question for them. Our question, why is this house still standing? Or what do you think happened in this picture? And so it could go different ways with that. They would make the claim, I think they got hit by a tidal wave. Here's the evidence of why I think so. They would look at the picture for different things that say, this is why I came to that claim. And then their reasoning might get into the fact that they know water is strong. They know it's sandy there. It looks like there's a beach, so it must be on the ocean. And then they would give that scientific reasoning. Other things is, this is a hurricane. So they might say, why do you think this house is still standing? And they're going to go into and maybe talk about, because it was built to withstand a hurricane. Here's the evidence that I have. It's off the ground. Then they're going to explain about hurricanes. Maybe they're going to do some research. So sometimes it can be just using their own prior knowledge. Other times they can research for SIR. Another way I also do SIR, which is the second page on here, and this one deals with an experiment. So just make sure when you're doing these pages, you're looking at which one you've selected. This is observe the science demonstration closely. So again, you could do an experiment right at the beginning of the class, have our question, you demonstrate it for them, and then they come up with a claim and the evidence and the reasoning for it. So maybe you're doing it for cloud in the bottle, and you say, what happened when I let the pressure out? They would make their claim, a cloud formed in the bottle. What evidence do they have? I saw the poof. They've been studying information about it, or they research it and they start talking about lower pressure, the temperature in the bottle, and start giving the science information. Then another way I wanted to share with you that I do it is, I use it also to help them to learn to write conclusions. So if they are doing this investigation, the effects of pressure on cloud formation, when they get to the back and they've done their graphs and all their data and they've written their summary, and we start to thinking about answering the question in more detail, a regular investigation journal has that conclusion. I also observed, I think this happened because. For this, I think this happened because. And I also observed. These sections will help. So sometimes I will give it to the kids after an experiment, and we will look at the first question, and they will start making their claim, evidence, and reasoning, and it's a nice brainstorming page. And then when we go here and they say, I think this happened because, it helps them to learn how to take all of this information and put it into a paragraph. So it helps them learn those writing skills in science. So I wanted to show those ways. And this is also digital as well. So you can type your question in ahead of time and print it. You can send it to it digitally to the students as an assignment. Maybe you send them the picture and this page, and then they type it in as do it as work. So both of those are digital, and we hope you find these pages useful. The observe. The last thing we have in this download is the identifying variables in experiments. So it is a great thing for before the lab to identify the parts of an investigation. So the way I would typically use it is for surveying before they begin. So they do a little bit more than just skimming and going, oh, this is what's in here, that's it. We're going to force them to look at it a little bit more. And so at the top, we have independent variable, dependent variable, control. So the definition of those to help them. And so if you're doing an investigation like this, the students would scan the pages, Scanning doesn't necessarily mean reading everything, or I should say surveying the pages, but they're going to glance, look at the topic, see what is there, and answer the questions on it. So it gets into what is the title. They'd write the title down. They'd go through and say, okay, where do I find the independent variable? And then they would identify what the independent variable is. In this case, it's amount of pressure. How many times are we changing the independent variable? So by this point, they know if you're doing some of these formal investigations, you're going to change it so many times. So they might look at the directions. They might look at the data table. Here they're going to see, oh, it's being changed 4 times. Then it gets into the dependent variable in the investigation is. They're going to look, oh, we're looking at the visibility of the cloud. Describe the control in the experiment. So at this point, you've shown them what the control is. And, you know, it might be a no treatment control. In this one, it's 20 pumps. They're going to compare everything to their first one. And then constants. They're going to go back to the directions, and they're going to focus on what things do we have to keep the same. We're changing the number of pumps. We're not changing the amount of water. And so it's going to get them to look at those directions a little bit and just start to think about what they're doing and gain a little bit more purpose for the experiment, and maybe increase their engagement and curiosity. How many trials will be conducted? List 3 materials needed for this investigation. So now they're going to look at what are we going to be using, and list 2 safety precautions we should follow. So they're going to think about those. And then you can have a little class discussion. And when you talk about the lab, they're going to be a little bit more familiar with what is going on. We also included a blank version of this. I shouldn't say blank, but it's all written in. It's completely editable. So you can go through and change any of this if you're defining it differently. If you're a higher grade level and you're looking at some of the other types of variables, you could add that in here. You could type in the investigation title if you want on the page that has the text boxes. You can send this digitally to the students. You can also project it on the board and do it as a whole class activity. And it is also great for a think, pair, share activity. So I hope you find this useful. This was the freebie that was in there. The last thing we have
So the last thing I wanted to go over is how I use this. So I make a folder at the beginning of the unit. Sometimes I have all the pages in there. Sometimes I'm adding stuff if I come up with other things. But I always start with that cover and then the driving question. This one is what causes clouds to form. And so that's what our whole unit is going to be about. And so the kids start by filling that out. Then I'll include the My Thoughts page in there. So we have that to refer back to. And this really helps me with my lesson planning. I've decided we're going to do a My Brainstorming activity on the first day. So I would include that in there. And then I have it. I've got multiple classes. This helps me to know where my students are at. We include the clues chart that we would revisit throughout. So it's right there for the students. When we are doing activities, they can go back and they can look when they're writing conclusions to things because they have all this information to help them. Then I have the vocabulary discovery sentences. I may not include all of the vocabulary discovery sentences from the beginning, but just as I do each unit, and sometimes I'll add pages throughout if I find there's other words I want them to learn, but we will refer back to that at the end, and that's very helpful. In this, I would include the exit tickets, but I might decide to cut them out and hand them to the kids and have them turn in. But for this one, I'm going to do 4 of them, and I'll do them at different days. I also do something called Science Show and Tell. This is not in this workbook. This is another product I have. But when I do demonstrations, it's like Read and React. They react to things, and I have those pages in there ready. So I'm planning out my unit. We're going to do describe the demo because I have demos like ice in a can. So I think I will do that with the students to just help expand and improve engagement. Then we have where did the water come from? That is one of my 30-minute science. I integrate that in with it, and then I pick one of those science notebooking strategies to go with that. So the page before it would go really well with it. Or I would also have the reading passage that goes with it, and I would do read and react with that. So I know I'm going to do this reading passage, so I'm going to include read and react that day, and they have the pages. And then that activity comes with a anchor chart. So after we do read and react, we can complete the anchor chart together. My students are going to do my cloud investigation. So I know we have that. And then through there, I might add some of the other vocabulary strategies and other activities. At the end of the unit, we've done so much on clouds. We're going to do a vocabulary Foursquare all about clouds so that we can show our learning as we end it. And then silly and serious questions. We're going to do vocabulary switch on pressure because our cloud investigation dealt with pressure. And then my students are going to write their own investigation. So this is a blank science journal that I have. So now they're going to come up with their own cloud investigation based on the questions they've been asking in the KWL. And then we would end with some sort of STEM challenge, most likely probably making a barometer. So this gives you an idea of how I integrate the pages into my units to make it a complete inquiry-based unit that I can also integrate into my own science curriculum and the items that you have that you like to do. So I hope you find this useful, and I hope you enjoy doing science notebooking. You can also add interactive notebooking and gluing to it as well. So if you have any questions, feel free to go to my stores question and answer page, or you can message me at KimberlyScottScience.com. So thank you very much.